Okay, guys, here we go. I'm going to try my best to explain what you're seeing here. We're going to go over rational expressions. The first thing I want to do is show you a basic shape of a graph. All right, so I have 1 over x, which is the y equals 1 over x is your very basic. You can see here the red line and another red line here. This is the graphing shape. It's not normal. It's not a line. It's actually broken into two pieces, all right? So rational expressions have something called asymptotes. It has two types, horizontal and vertical. It also has one called an oblique. We probably won't get to that. We'll just try. We'll see what happens. All right. So on that, we're going to look at this red shape. It has both a horizontal and a vertical asymptote. Okay, so the horizontal is, of course, a line that runs back and forth like this, and a vertical is a line that runs up and down. So if you look at this red line, the horizontal asymptote is the x-axis, which means it's y equals 0. That's the horizontal asymptote. And then the vertical asymptote, the one up and down, is the y-axis, which is x equals 0. All right. So let me also talk about domain and range with this same shape, and then we'll see more practice with it. Domain, of course, goes with x values, and range goes with y values. So the domain is, on this graph, is everything except x equals 0. If you look at the vertical asymptote that I just talked about, it was the y-axis, which is x equals 0. Well, the domain is everything except x equals 0. So notice the connection there, okay? The horizontal is y equals 0, all right, which is the x-axis. Okay, and the range is all the y values, is everything except y equals 0. Okay, so let's look at that also algebraically. Why can the x not equal 0? Well, if I plug in 0 for x, which is domain, okay, x is domain, so why is domain everything but at 0? Well, if I plugged in 0 here, you get 1 divided by 0. That's undefined. That's why it can't equal 0. That's why it's considered an asymptote. It gets really close to that line and will not cross it because it cannot equal 0. Well, why is it the y value, the range, can't be 0? Why is that? Well, think about any value you can plug in for x, okay? If you can plug in a really big negative number, you're not going to get 0. If I plug in a really tiny negative number, like negative 1,000, I'm still not going to get 0, all right? If I put in like 1,000 here, or 1 over 1,000, it doesn't matter. No matter what I plug in for x, there's no way for the answer, the result, to be 0. And that's why the range is also limited to everything but 0. Again, you see that graphically with those horizontal and vertical lines. Okay, now let's talk about transformations with this. All right, this +2 clearly means it went up 2. Notice what happens when I click on the graph. The red is the original, the blue is the new. Notice it went up 2. Now, there is still a vertical and a horizontal asymptote. The vertical is still the y-axis, so therefore x equals 0. The horizontal is right here, where it is y equal 2, all right? Let's look at this instead. Let's take that one away. Now let's talk about if I do -2 in the bottom. That means it went right 2. Notice the green graph is right 2 of the red one. All right, and I notice then this still has the same horizontal asymptote, which means y equals 0, but the vertical asymptote has moved to the right 2, which is x equal 2. These transformations will move those lines. That's extremely helpful for graphing, okay? And you'll see that in a minute. Let's talk about one other situation. We've moved up and we've moved left, or basically right. Now let's talk about reflecting. If I reflect this over the x-axis, which is what that negative does, you'll get the purple one, which if you think about it, if you took the red one, you reflect it over, that's what you get, or you take the red at the bottom and you reflect it over. So again, the negative 1 over x would be the purple one. All right, and we'll bring the red back. Okay, so on the graphing, one of the worksheets, you actually have to graph. Now, I will show you how, but you can always, again, put all this in your graphing calculator or go online like this, and then just kind of select values as you go. All right, but here is what this would look like. All right, it went left 1, down 2, and it stretched vertically by 3. All right, now that would be very challenging to graph, okay? But I'm going to show you how to draw the vertical and horizontal asymptote, the lines, and then we're going to pick some values and then I'm going to show you how to sketch the graph, okay? But I want to at least show you on here. You might even find it easier if you take the original graph and make it 3 over x instead of 1 over x. This will allow it to be, now if I look at the red one, it looks like all it did was move left 1 and down 2. Give me the black one or the red one here. Left 1 and down 2. It does look more like that's what's happened. Okay. Now let's look at actually putting this to practice with graphing and finding those things we need to find. So I'm going to go ahead and I think I can hit stop share on this one, and we're going to go to the whiteboard. All right, so now we have the whiteboard. It's time for me to show you how to do some of the problems on your worksheet. All right, so here it goes. Maybe I can get that to move over. Maybe I can't. There it is. Okay. So I'm going to look at your first worksheet that you have, which is the simple rational functions. I'm going to look at number 2, all right? So what you have here is number 2, it says f of x equals 4 over x minus 1 plus 1. Okay, it asks what are the vertical asymptote, horizontal asymptote, domain, and range. Okay. The vertical asymptotes you get from the denominator equal to 0. So I'm going to set this part right down here equal to 0. X minus 1 equals 0. The vertical asymptote is equal to 1. And this means the domain, all right? And you can write it as all real except x equal 1. Isn't that nice? So when you get the vertical asymptote, you've immediately found the domain. Okay, now let's do the horizontal asymptote. All right, the horizontal asymptote you get from this right here. Now that's with these simple transformations, that's where you get it. Okay, so the horizontal asymptote, you get, because it went up 1, it is y equals 1. That's all there is to it, except I almost wrote something else. I don't know what I was going to write. All right, 1. And then the range, it's everything. So this is range, sorry. That's okay, I'll write it nicer. The range is everything except y equal 1. All right, that's how you do those problems in number 1, 2, 3, and 4. If I do not add anything on, okay, if you don't have anything, that means that this would be 0 because I didn't add anything. All right, if I don't have anything going on down here, okay, if there's just, it's just over x, well, that means that this would be x equals 0, and that would be the answer there. So I'm helping you by telling you that. I'm helping you with number 1 and like number 4. Okay, this is like number 4, and this is like number 1. All right. Okay, now let's scroll them down on that worksheet. We're going to actually graph some. All right, so let me show you how that works. Let me first of all get some straight lines here for our graphing on this thing. Okay, somewhat straight lines. Okay, the equation is 3 over x plus 1 minus 2. Okay, so let's talk about the horizontal and vertical asymptotes. Well, I get the vertical asymptote by setting this bottom thing equal to 0, x equal -1. So I'm going to go where x is -1, and I'm going to draw a vertical little line, dashed, okay? Because it's not really part of the graph, but it's sure helpful. Then for the horizontal, I know it's y equal -2. So I'll go down here where -2 is, and I'll draw a horizontal little line. Okay, because I know the basic shape of this graph is going to be, before I do anything else, it's going to be, oops, sorry. It's going to be something like this. That's terrible. I will try to draw that again. Will be, and where it doesn't cross the x-axis, so sorry about that. Hopefully. Now all I need to do is to find a couple of points. I'm going to plug in 0 for x and see what happens. If I plug in 0 here, so we got 3 over 0 plus 1 minus 2. You're going to get 3 over 1, so 3 minus 2. I guess I get 1. So the point 0, 1 is on this graph. So I'm going to go 0, 1. I'm going to plot that point. And because I know the basic shape here, I'm going to allow you guys to do just like this. Okay. And then guess what? That means over here, what do we have? The same idea. Okay. You don't have to plot detailed points. I want the most critical thing for you to learn is to draw those vertical and horizontal asymptotes and know the shape. It does that shape. Okay. However, if I had a negative in front here, right? If there was a negative right there, then the shape wouldn't be the direction I have it. It would change directions, right? It would be over here, like a purple earlier versus the red. Remember the purple flipped directions? Okay. If that has a negative, it would do that. Okay. Let's go to another problem. All right. That might take care of the first worksheet. And it does. Okay, so now let's go to the other worksheet. All right. These examples should help you with the first worksheet. Now we're going to look at graphing rational functions, and we'll go from there. So let me clear this board. And here we go. We'll see what I can type in. Okay. So we're going to have 1, and it's going to be, I don't know if I can do what I want. Okay, so I'll just have to scratch writing. I'll just have to write it by hand. So never mind. We're going to have 1 over 3x squared plus 3x minus 18. Notice this is not in transformation notation. So you can't just like say left, right, up, down, all that. It's great when it's in that way because that is easy. That is a lot easier. But this one, you're going to be able to still, there are some things that stay the same. Vertical asymptote you get by setting the denominator equal to 0. So I still get to do the vertical asymptote by setting this equal to 0. So I'm going to go 3x squared plus 3x minus 18 equals 0. This will help me get the vertical asymptote. Okay, so I'm going to pull the 3 out, leaving me with x squared plus x minus 6. I'm going to factor x, 3, 2, plus and minus. And if I set those equal to 0, x equals 2, x equals negative 3. Oh my goodness, Ms. Flowers, are you saying some of these can have more than one vertical asymptote? Yes, it can. All right, so that takes care of the vertical asymptote. Of course, then you also need to look at, it also asks us to find some x-intercepts. Well, the x-intercepts, you get x-intercepts. You set the numerator equal to 0. In this case, that's num for numerator, okay? We don't have anything to set equals, so it doesn't cross the x-axis. There are no x-intercepts. And by the way, I'm doing number 1. If you wonder what number I'm coming, this is number 1 from that other worksheet. No x-ins, okay? The next thing it says is holes. We don't have holes. I'll talk about those when I go over a different example. And then a horizontal asymptote. Okay, so we have some new rules for horizontal, okay? So let's talk about the horizontal real quick. I'll erase the x-intercept stuff so I have more room for the other. All right, so here we go. Horizontal asymptotes. All right, when they're in lovely form that we had before, you just see how much it goes up or down, and that takes care of it. But when it's not in that form, you have 3 possibilities, all right? If you look at the expression, look at the degree. Now, let me remind you what degree is. Degree is the highest exponent. All right, if we're going to look at the highest exponent on this graph, when I look at the highest on the top, I don't even have an exponent, which by the way means 0. Okay, and in the bottom, the highest exponent is 2. You are looking at the numerator's exponent and the denominator's exponent. Okay, when I say that, so this is important. So in this situation, we have the degree on top is 0, and the degree on bottom is 2. So this means it is. And I draw triangles to help myself with this. This means bottom heavy. If this is a situation, the horizontal asymptote is y equals 0. Done. If we had this flipped, well, that doesn't make sense in this problem, but in a different problem, let's say if you had the degree on top was 3 and the degree on bottom was 2, okay? Then that means it would be top heavy. And by the way, that means there's not a horizontal asymptote, okay? And then finally, we'll look at in a minute if the degree of the numerator is equal to the degree of the denominator. Like let's say they're both x squared, that's the highest exponent on both top and bottom. They're the same, then the answer will be what they call a ratio. It's y equals, and I'm going to just put a hashtag divided by hashtag, and that means it's the coefficients. All right, you can call them the leading coefficients if you want. It's the coefficients of the highest degree. All right. Let's see some examples. What now we found on number 1, we found the vertical asymptotes. There are no holes. The x-intercepts does not exist. And horizontal asymptote is on this particular problem. So we'll know this is our situation. It's y equals 0. And I am not concerned about discontinuity. Okay. I'm not going to go over that. Okay. We're going to cut that. All right. So now let's look at number 3. All right, so look at number 3. I'm hoping you have the worksheet. I'm going to try to write it up here. All right. You have x cubed minus x squared minus 6x divided by negative 3x squared minus 3x plus 18. All right, so I've got to find, well, I don't know about holes. We haven't had that. So we need to find the vertical. Well, what happens, I need to factor both top and bottom. All right, so I'm going to pull an x out of the top. We get x squared minus x minus 6. Okay, that can factor again. So we're going to go x here, 3, 2, negative, positive. There we go. All right, I just factored the top. Now I'm going to factor the bottom. I'm going to pull a negative 3 out, leaving x squared minus x minus 6. Okay. Oh, that's the same thing. Did I do the exact same thing? Did I write it down correctly? Yes. But I pulled out here. I got x squared minus x minus 6. And this one, I pulled the negative 3 out, and I got x squared. Oh, plus. There you go. I didn't think it was supposed to be the same. Okay, negative 3. I'm going to factor this. X. This is going to be, can I do 6, 2, and 3? Yes, I can. 2, 3, but I need a positive 3 and a negative 2. Good? All right. So now that you have it factored, we can find the vertical asymptotes. We can find the horizontal. We can find the x-intercepts, and we'll talk about the others. So let's talk about the vertical asymptotes. That's the bottom. It's set equal to 0. So that means this equal to 0 and that equal to 0 means x equal 2 and x equal negative 3. That's my vertical asymptotes. My x-intercepts, we get by the top equal to 0. All right. This is my x-ins. That means x equals 0, x equals negative 2, and x equals 3. That's my x-intercepts. By the way, we still don't have holes. I will tell you in a minute when we get done with this what would create a hole. All right. X-intercepts, vertical asymptote, horizontal. Okay, that's the thing. We got to look back at the beginning. All right. Look at the degree of the top. Okay, so back at this problem. The degree of the top is 3. Okay, so degree of 3 on top, degree on the bottom, degree of 2. Okay, so this is top heavy. Oh, not 1. The way I remember it is if that building was built, there would not be a building. It would crash. Okay, if you had a building that was built like a triangle upside down, I'm pretty sure that would not hold up. Okay, they'd have to have poles or something to support it. All right. So that takes care of our vertical asymptotes, our x-intercepts, and a horizontal. Again, I'm not concerned about discontinuity. Let me talk about holes, all right? If this had factored where it was plus 2 right there, okay? Then because I can actually go through and circle and cancel these, I can cancel both of those, that becomes a hole in the graph, all right? We'll look at that more later. You'll see that pop up. We're going to have to somehow balance and double up on this stuff. So just hang in there because the next couple of weeks might be a little rough, but we're going to get there together, okay? All right, so here we go. Let's practice some more on these. All right, let's do another one. All right, let's do another one that I can graph to show you how it works. All right, let's do number 5. F of x equals negative, and then you have 4 out front, and you have x squared minus 3x. All right, I need to find the vertical asymptote. That means the bottom equal to 0. Let's factor an x out, leaving me x minus 3 equals 0. That means x equals 3, 0, and 3. All right, I don't have any x-intercepts. And then horizontal asymptote. Let's talk about that real quick. The degree of the top is 0. The degree of the bottom is 2. So this is this way, bottom heavy, so y equals 0. Okay, so we got our vertical and horizontal asymptotes. That's huge. So here we go. We're going to draw our graph. I'm going to put the vertical asymptotes. X equals 0. That's right on the x-axis, okay? X equals 3. 1, 2, 3. Y equals 0. Okay, I'm going to draw that here. It's on the y-axis. Okay, this is weird. Okay, just hands down. This is weird. Put it in your graphing calculator. Type it in. That way you can figure out what the shape will look like, okay? The other way to do this, other than just putting the graphing calculator, is pick points, all right, along the graph. But this one will still do, it will do this, this, and this, okay? Again, what is critical to me? What's important? Draw those vertical and horizontal asymptotes. Then grab your graphing calculator and use it to help you. All right? Got it? All right. Let's do another one. Let's do number 7. Trying to give you all as much help as I can. All right, you got f of x equals x plus 4 over negative 2x minus 6. Okay, let's find the vertical asymptote first. The bottom equal to 0. All right, so add 6, divide by negative 2. Looks like it'd be negative 3. And then let's do the horizontal asymptote. Okay, the degree of the top is 1. The degree of the bottom is also 1. Hey, they're the same. This is the one that said it's the ratio. Okay, so I'm going to put a 1 there. That means it's the coefficients. So that means that y equals a negative 1/2 is my horizontal asymptote. Okay, now I'm going to draw my axis. I'm going to make them a little, yeah, that'll be good. Okay. Okay, I'm so good at straight lines. Sometimes I am, and sometimes I'm not. Okay. That's better. Okay, now we're going to graph this. We need to graph the vertical, which is just negative 3. So we only have 1. 1, 2, negative 3. And y equals negative 1/2. So if I say that's 1, then we'll just do negative 1/2, like in between that. Okay. And then we know the x-intercept. If I want to, I could set the top equal to 0. That gives me the x-intercept. So x equals negative 4. So I'm going to go where x is negative 4. Okay, x crosses right there. Negative 4, because that's negative 3, right? So that means I already know a little bit about this graph. It's going to do this. Just by plotting 1 point, I know what the graph's going to do. And notice I'm not requiring a lot of other points. I just want the general idea. All right? This is huge. You're doing great. Okay. Again, don't worry about discontinuities, which is going to pop up on there. All right. I think. Let me see if I can do. I have another graph that I need to do. I don't know. Maybe one more. Let's do number 11. No, not 11. I do not want to do 11. Number 13. Number 13. Let's do 13. Last one. So if you're bored of the video, hang in there. We're almost done. Okay, so the top you got 2x squared plus 10x plus 12 divided by x squared plus 3x plus 2. I'm going to set the bottom equal to 0, but probably I need to factor first. X, 2, 1, plus. Let me go ahead and factor the top while I'm at it. Pull a 2 out. I'm going to have x squared plus 5x plus sign. Sorry, my handwriting is getting worse. But if I factor that, I get 2. X x, 2 and 3, and both are plus. This one's actually really critical that I did this one. I'm so glad I chose this one. I'm going to put the denominator. Now they're on top of each other. Do you see that? I just moved this one over and put that there. Okay, what do you notice that's on the top and the bottom right here? The same thing. So this means there's a hole on this graph when x equals -2. This is going to be very important. Okay, so then the vertical asymptote, looking at this one, is x equal -1. And then we can get the, well, we got to look at the horizontal asymptote. We don't look at that. We get that from right here because the degree of this one and the degree of this is the same. So it's just going to be degree of 2 over degree of 2. They're the same. So the horizontal asymptote is y equals 2. So I've got my horizontal asymptote. I've got my vertical asymptote. I've got a hole. All right, let's start graphing. If I need to, I'll get the x-intercept. All right. So I'm going to graph -1. I'm going to draw that little dashed line. Representing, I know that's a horizontal asymptote. I'm going to go to y equals 2. All right. I know I'm not going to worry about the hole right now. Let's just look at what shape does it do. I don't know for sure. Let's just find the x-intercept real quick so I'll know what the graph will do. If I set the top equal to 0, x equals -3 is an intercept. So I'll go where x is -3. 1, 2, 3. So it means it hits right here. So that means the shape of the graph will do something like this. All right, and it says when x is equal to -2, there's a hole. Well, what that means, and I'm probably not going to, this is probably not going to work out so good. I'm going to try because it's hard to do. So I'm going to just draw with a different color. On yours, you can actually erase with your eraser. I just can't with this. It'll erase the whole line. But when x is -2, I'm going to go to this spot, and I'm going to draw down a dot. Yeah, we're good. We're going to draw down to that graph right there. Right there, you're going to put a little open circle. Because at that spot, there's actually a hole in the graph, okay? So that's what that would look like if you had a hole in the graph. You don't have to have the little purple line running down to it, but I just wanted you to see it. You put a little hole there. If you have an eraser, you actually erase the little line and put a little hole, but I can't do that with my computer program. All right. Like I said, I'll provide a Zoom session later if you need more help. All right, y'all have a great day. Bye.